Welcome back. Today we'll finish 2-3, looking at the zeros of a quadratic function. So here we have Marco at a multi-level driving range, very similar to Chelsea Piers or Topgolf. And he's on the second floor, hitting the golf balls at a height of 32 feet. So I'm going to put 32 here to represent that height. We know that the golf ball is going to have a parabolic path, eventually coming down to the ground. The height of the golf ball is represented with this equation, and x represents the seconds after Marco hits the golf ball. For this problem, we want to figure when does the golf ball hit the ground. Now, we have to remember that when something hits the ground, it's going to have a height of 0, right? And that is why we call it a 0 or x-intercept. So we're looking at when does this function equal 0. So just like when we're solving, we set this equation equal to 0. So we get negative 16x squared plus 16x plus 32 equals 0. Now, the next step is to factor, but there's also GCF in here. We can divide everything in here, each term, by negative 16. So if I divide both sides by negative 16, and I can do that because it's an equality. We don't need to just factor it, right? I can divide both sides by the same number. So I'll have x squared minus x minus 2 equals 0. Now I'm looking for two numbers that multiply to make negative 2 and add to make negative 1. So that'll be negative 2 and positive 1. So this will factor into x minus 2, x plus 1. So if we know that those are the factors, we could set them equal to 0. And so our solutions are x equals 2 and x equals negative 1. Those are our zeros. But remember when we looked at this path of the golf ball, we're looking for when it hits the ground over here, not when the parabola hits the ground over here, right? So this is a parabolic function here, but it doesn't, this point doesn't represent the time, right? Because that's before Marco hit it. So we have to make sure that we're looking at the word problem and using the value that best represents the situation. So x equals 2 is the 0, but we're asking it in words. When does the ball hit the ground? So we're going to put it in the unit of time, 2 seconds. Now for the next problem, we're asked to figure out the interval that a quadratic is positive. So first we have to figure out when it equals 0. So I'm just going to make a little sketch here. We know that this parabola is going to open up, right? So the x-intercepts are the zeros, and we want to find these two intervals. It's probably going to be the 0 and then all the way to positive infinity, and then the lower value for 0 to negative infinity. So remember, above the x-axis is the positive. Below the x-axis is the negative. You can think of it above the water and below the water. So first, whenever we solve, the first step is to find the zeros. So we're going to solve this and set this equal to 0. Now we're looking for two numbers that multiply to make -3 and add to make -2. And so two numbers that will multiply, let me write this a little bit bigger because it's getting too scrunched. It'll be -3 and +1. This has a leading coefficient of 1, so we know we can factor it right away into x minus 3 and x plus 1. When we set each of those factors equal to 0, our zeros are going to be 3 and -1. So on this graph, this point would be -1 and this point would be 3. But remember, we're not looking for the zeros. We're looking for when will this function be positive? So when it's positive, we know that it'll be to the right of 3. And if we wanted to make sure, we could always plug in a point and say, all right, what do you get when you plug in 4? Well, you get 16 minus 8 minus 3, and 16 minus 8 minus 3. That's a minus. That would be 5, and that's positive. We know that it goes below the axis between -1 and 3, so this is where it's going to be negative. And then we know it's going to be positive again, anything to the left of -1. And if you want to check, you could plug in another point, like -2. Because when x equals -2, you get 2 times, well, -2 times -2, which is 4, plus 4 minus 3. And again, getting 5. So that makes it positive. Now we're going to say the intervals. So that's going to be from -infinity to -1. And since we have two intervals, we're going to show that with a union. And the second interval is from 3 to infinity. Remember, we do not include the zeros. We're not using brackets because it's asking when is it positive. For our last example, we're going to write the equation of a parabola from factored form into standard form, given the x-intercepts and the third point. So remember, if we had a sketch and we knew that there were x-intercepts at -1 and -3, then the parabola would touch the x-axis at those zeros. We know a third point, -220, is going to be way up here, so we know the parabola is going to open down. So in factored form, we're going to have to use those zeros. So remember, the equation is going to be a times x minus the first 0 times x minus the second 0. To get those factors, we can set these answers equal to -3 and -1. Those are our zeros. To find the factors, we're going to have to now set them equal to 0. So we have x plus 1 and we have x plus 3. So those must be our two factors. Now when we plug that in, the last step we need to do is to find a. And we're going to use the third point here. 20 is our y, and negative 2 is the x, to make sure we can figure out the a. So when I simplify this, this is just going to be 1, and this will be negative 1. So 20 equals negative a, so our a must be negative 20. So when I write the equation, we know that it'll be y equals negative 20 times x plus 3 and x plus 1. In factored form, that would be perfect. In standard form, we're going to have to FOIL. So we get x squared plus 3x plus x plus 1. Combine like terms, and we get x squared plus 4x plus 1. And distribute the negative 20. We'll get negative 20x squared minus 80x minus 20. Just before we leave, just want to make sure we review that we have the factored form, and you can see that it has, if we had the two factors, it'd be x minus the first factor times x minus the second factor. Those two zeros help us figure out those factors. And the intervals are shown with those boundaries. So those zeros are right here. And anything that's above is positive. Anything that is below the x-axis would be negative. I hope this was helpful, and see you again next time.